Hello, assalamu alaikum everyone. This is Shujah and today we are going to get started with AS level trigonometry. So we are going to study what is trigonometry and what are quadrants, or ASTC to be specific. What is a base angle? How do we find the two angles of a given angle? And lastly, how do we find cos 150 without using a calculator, given we have using a calc, given we have the value of cos 30. So yeah, let's get started everyone. So first of all, let us make a Cartesian grid. So this grid consists of a y-axis and an x-axis. And let's say this is some circle, and this circle has radius 1. This is the perpendicular, and finally this is the base. So we can see we have formed a right angle triangle. Okay, and we can label each respective side, the base with x and the perpendicular with y. So here, if we can see, we can even form a Pythagorean formula. So the formula is going to be as follows: x squared plus y squared equals 1. So x squared is the base, y squared will be the perpendicular, and lastly the hypotenuse, which is the longest side, is equals to 1. So the general formula, the general Pythagorean formula is, for those of you who do not remember, so it's b squared plus p squared equals h squared. So this is the same as this. We can move on to the most famous ratios of SOHCAHTOA. SOHCAHTOA. So let's say we are given with some angle theta, and we know that, for those of you who do not know, SO stands for sine theta equals opposite over the hypotenuse. So is basically sine theta equal the opposite side and divided by the hypotenuse. So for this triangle, the opposite would be the side that is opposite to this angle. So this is some angle theta, and the side opposite to this angle is y. Therefore, sine theta equals y upon the hypotenuse. So we know the hypotenuse is the longest side of a triangle, and in this case it is the radius, or the value 1. So anything divided by the number 1 is the letter or the number itself. So now that we've got this aside, let's move on to the ratio of cos. So cos, which starts by C, stands for cos equals to adjacent over hypotenuse. So what is the adjacent in this ratio? So the adjacent is basically the side that is beside the angle. So in this case, if this is some angle theta, so this red side is going to be the adjacent side to the angle, and of course the height will be the longest side, or the radius. So this was 1, this is 2. So cos theta equals x over 1 because of the hypotenuse. So once again, cos theta equals x. Moving on to the ratio of tan. So tan starts with T, TOA. So this is going to be tan theta equals opposite over adjacent. Opposite, so O for opposite and A for adjacent. So this becomes opposite over adjacent. So tan theta in this case, so the side that is opposite to the angle is y, and the adjacent is of course going to be the side that is beside the angle. So this is our last ratio. Now we can see, if someone has noticed this, very well done, that we can see that sine theta equals y and the cos theta equals x. So can we say that tan theta equals sine upon cos theta? So can we say that tan theta is identical to sine theta upon cos theta? Because we can see that sine theta equals y and cos theta equals x. And if we plug in the original sine theta and the cos theta, so we can see that we get, in fact, we get an identity. So this thing is known as an identity. And in fact, we are going to study about trigonometric identities in our next video. So this is in fact the one of the first identities in our syllabus. We can also form a second identity. So I'm going to erase this area. So how do we form the second identity? So this identity is also an important identity and a very helpful one. So since we know that sine theta and cos theta equals x and y, so can we plug in or simply substitute these values in here? So this will become cos theta whole square plus sine theta whole square equals to 1. So this becomes cos squared theta. Remember, the squared never comes on the angle. It goes to the cos only. So sine squared theta equals 1. Or we can reshuffle this. So this becomes sine squared theta plus cos squared theta equals 1. So in fact, this is our second most important identity in AS level trigonometry. So this is the second identity, and this identity is also given you in the formula sheet. So we have in fact derived two identities just from these two variables. Now we can even derive two more identities, and I won't be solving any questions for the identities. I will do it in the next video hopefully, and then we'll see how these identities are applied in the questions. But for now, I'm just giving you the concept. So we know that sine squared theta plus cos squared theta is an identity. So this is the second identity. So from this we can form a third identity, which is going to be sine squared equals to 1 minus cos squared theta. So I simply made sine squared theta the subject and then rest its algebra, and this gave us sine squared theta on the left hand side, giving us the third identity. So this is the second, this is the third. Let's make our fourth identity. So for those of you who guessed it, very well done. So cos squared theta equals 1 minus sine squared theta is our fourth identity. So we can see we have formed four identities, and these are the only identities that we are going to use in our syllabus, and there are no other identities other than these four. So that is it for the concept of trigonometry. Now let's move on to the concept of quadrants. So let's write a new heading: quadrants and ASTC. So let's make a grid and label this as ASTC. So the A in this ASTC stands for all, or to be more specific, all ratios in essence, sine, cos, and tan theta are positive. So what am I even saying here? So the let's just label each of these four sides. So this starts from 0 and ends at 360 degrees. This ends at 90 degrees. This is 180 degrees. And this is 270 degrees. Okay. So if I go from here to here, this is 90. And then this is 180. Then this is 270. And finally 360. So one complete rotation. So now what do I mean by this? Let's say this is some angle. Let's say this is 50 degrees. So if I calculate sine 50, cos 50, and tan 50, guess what? I'm going to get all positive values. So if I plug in the values in the calculator, so let's plug in sine 50. So this must give me a positive value, which confirms our claim. Similarly, if I plug in cos 50, this will also give me a positive value. And finally, tan 50 should also give me a positive value, and it does. We do not care about the values themselves, we care about the signs only. Since I claim that the ratios of sine, cos, and tan are going to be positive. So if I plug in sine 60, sine 70, sine 80, any angle between 0 to 90 degrees, so all of these ratios are going to give me a positive answer. Let's move on to the second quadrant. Oh, by the way, I might not have mentioned this, but these blocks, as you can see, these imaginary blocks are known as quadrants. So these are known as quadrants, and the counting begins from the right hand side, so from the top right. So this is the first quadrant, or let's say Q1. This is the second quadrant, Q2. This is the third, and finally this is the fourth quadrant. So moving on to the second quadrant, which is Q2 in this case. So in this quadrant, the ratio of sine is positive, of sine theta is positive. Meanwhile, sine theta is positive. Meanwhile, cos theta and tan theta are negative. So what do I mean by this? So let's say I plug in an angle that lies between 90 and 180 degrees. So let's say I plug in sine 150, for example, 160, let's say. This is going to give me a positive value. And since I claimed earlier that the ratio of sine theta gives us a positive value, so this confirms our claim. However, if I plug in cos theta, this will give me a negative value, and so will tan theta. So let's see, and yes, it does. So it is giving us a negative value. So see how the calculator works. So whenever you're applying a ratio, or let's say tan theta, and the angle is between 90 and 180 degrees, and you get a negative answer. So the logic behind that negative sign are these quadrants. So let's move on to the third quadrant. So let's say I have some angle, and that angle is, for example, let's say since it is 180 to 270, let's say it's 200. So if I calculate cos 200 or sine 200 or tan 200, what am I going to get? So let's claim that any angle between 180 and 270 degrees, and if we are applying a ratio of 10, we must get a positive answer. So this is my claim. So tan theta is positive while sine and cos are not. So sine theta and cos theta are negative or are not positive. So this is my claim. So let's confirm our claim. So going back to the calculator, let's try 200, and yeah, it does give us a positive value. But let's try sine 200, it gives us a negative value. And similarly, cos 200 must also give us a negative value, and it does. Therefore, we have once again confirmed our claim. And finally, we are going to calculate the fourth quadrant where cos is positive. So here cos is considered positive, cos theta is positive, while sine and tan theta are not. So sine theta and tan theta are negative. So let's say, since this is 270 to 360, let's say cos 290, sine 290, and tan 290. So cos 290 must give us a positive value, while the other two must not give us a positive value. So cos 290 gives us a positive value, which confirms our claim. Sine 290 gives us a negative value, which once again confirms our claim. And lastly, tan 290 once again gives us a negative value. So this is essentially ASTC. So how do we use this? We will see this in a moment, but before that we have to learn a few things more. So let me just erase this. So every angle in the world, and any angle in the world, has two values. So one is the basic angle. So on a Cartesian grid like this, there are four basic angles. And what is the basic angle? The basic angle is essentially the shortest possible angle, shortest base angle. It's also known as the base angle or the basic angle, and is usually denoted by alpha. Basic angle is the shortest possible angle from the nearest x-axis. So nearest x-axis would mean the x-axis line. So this is the x-axis line. So this is the basic angle. So any angle in the world has two angles. One is the basic angle and one is the original angle. So what is the original angle? So the original angle is basically the angle that is formed by going anti-clockwise. So what do I mean by this? So let's say this is a Cartesian grid and the basic angle is somewhere here. So this is 0 to 90, 180, and 270, and 360. So the original angle is the angle formed by going anti-clockwise. So going to this base angle, so the angle that forms by going anti-clockwise up to the base angle is known as the original angle. So this is in fact the second value Okay, the second possible value. So in this case, we know that the straight line is 180 degrees, and since a base angle has been formed from this 180 degrees, this leaves us with 150 degree. So in order to complete an entire rotation, we will have to subtract 180 minus the base angle. So in the second quadrant, we subtract 180 minus alpha, or in other words, where sine is positive, we subtract the basic angle from 180. Similarly, in the first quadrant, which is Q1, this was Q2, here all ratios, are positive. Furthermore, in this quadrant, the original angle is the same as the basic angle. So we do not subtract, add, or do nothing. We simply say that the original angle is the same as the base angle. So I'm going to denote it with alpha, so base angle. Let's move on to the third quadrant. So let's form another base angle, this time in green, and this is, let's say, this is a base angle, and let's say this is 50. So now, in order to complete this rotation and to get to this diagonal line, I'll have to add something. In this case, I will have to add 50, or the base angle. So in order to get to this line, so in order to find the original angle, which is basically the angle formed by going anti-clockwise up to the base angle. So in this case, if this were the base angle, we'll have to add something in 180, because 180 is one complete rotation. So once we have arrived at this point, we have to go beyond this point as well in order to get to the diagonal line. So in this case, we will have to add 180 into the base angle, or in this case, I'll have to add 180 plus 50. Okay, or in this case, in the blue case, where we were going from here to this base angle, we had to subtract 180 minus 30. So in this case, 150 is the original angle, or in this case, the original angle will be 230. So 230 is the original angle. Finally, making our last base angle, since there are 4 base angles, so this is going to be the last base angle. So let's say this base angle is 60 degrees. Okay, so I start from here. So we always move anti-clockwise. Remember, we always move anti-clockwise. So in order to get to this line, so in order to find the original value, I'll have to subtract something from 360. I'll have to subtract the base angle from 360, or in this case, I'll have to subtract 360 minus 60, or 360 minus alpha. So 360 minus alpha will basically give us the original angle. So this will be equal to the original angle. So in other words, for this quadrant where tan is positive, where tan theta is positive, we do the following. And where cos is positive, we subtract 360. And we can even write this entire thing like 360 or 180 into another form that is known as the radian form. So the radian form is pretty simple. It's just a way of measuring angles, just like degrees. There's another way of measuring angles. So radian is basically a unit of angle. Radian equals to unit of angle, of measuring angles. So this is in fact far more accurate than degrees, and there is another unit known as gradients. This is essentially the worst unit that people could have come up with. So this is basically highly inaccurate. So we just don't even care about this unit. So how do we convert degrees into radians? So just remember it as a fact that 180 degrees equals to pi radians. So pi radians or radians. We write rad for short. So this is a universal fact that 180 degrees equals to pi. So now what if I want to calculate 360 degrees in terms of pi? So what is 360 in terms of pi? So it must be some radians, x radians. So by simply calculating it via the ratio method, so the ratio method is as follows. So 360 and x. We know that 180 equals to pi radians, so 360 must be x radian. So simply cross multiply, we get 360 pi equals 180x, and 360 pi, divide both sides by 180, 180. So this gives us 2 pi, and this is simply x. So in other words, 360 is exactly the same as, is identical to 2 pi. So both of these units are exactly the same. However, this is in radians and this is in degrees. So that is the only difference. So let's rewrite the previous angles we did. So here we go. So 180 minus pi is going to be minus alpha, is going to be exactly the same as pi minus alpha. And we knew this was in quadrant 2. So quadrant 2. And in Q1, the original angle, base angle, equals to the original angle. Q3 was 180 plus alpha or pi plus alpha. And lastly, Q4 was 360 minus alpha, or in this case 2 pi minus alpha. And we know that in the first quadrant A, we know that ASTC. So ASTC. So we are essentially done with the concept. So let's solve some questions and then wrap it up for the day. So first of all, we are given with some domain. So this thing is known as the domain, and you will better understand it in functions once I will teach functions. But for now, just remember this is a domain. So the examiner asks us to calculate sine x equals 0.4. So how do we calculate sine x equals 0.4? So in order to calculate an angle, we simply inverse. For example, if we are adding, so let's say 4x plus 6 equals 10. So in this case, what we do is 4x, so we subtract both sides from 6. So this gives us 4x plus 6 minus 6 equals 10 minus 6. So this cancels out the plus 6 and minus 6, leaving us with 4 on the other side. And similarly, we divide both sides by 4. So this gave us 1. So we are doing the same, but in sine we cannot divide this by 4. a 0.4. We cannot divide sine, so we cannot do 0.4 divided by sine. Okay, this is nothing. So in order to calculate the angle, we take the inverse of the sine of the original sine. So in this case, sine, so we press shift and simply press the sine button. So this will give us the inverse and 0.4, giving us 23.58. Oh, this is 0.4 and 23.58 degrees, since we are dealing with degrees. Now, as I said, that each angle had two original values, had an original value and a base angle, so two values. So since the ratio of sine is positive, so in this case the first possible value is going to be in the quadrant A. So this is lying in A. So if you make a quadrant, so since the angle is positive, since this thing is positive, we simply say that sine is positive as well. However, we also want to find the second value, and we know that sine is positive in this quadrant, in the second quadrant. And what we did in the second quadrant was simply subtract 180 from the angle, from the base angle, and we say that the two possible values of sine are 180 minus, so 180 minus 23.58. So this is going to give us 156.42. So these are the two possible values of sine. Let's solve the last question for the day. So this is going to involve radians, and it's very easy, and I will just show you how to solve the given question in terms of radians. So let's say this is some domain 0 to x and 2 pi. And we studied earlier that 2 pi is same as 360. So this is a question, cos x equals negative 0.4. So alpha equals cos inverse 0.4. We will consider this negative sign later, and we'll see how we use this negative sign. Now we are dealing with radians. In the previous question, we were dealing with degrees. So in order to convert from degrees to radians, we press shift on the calculator, press mod after pressing shift, and then you will see on 3 you will see DEG. So DEG stands for degrees, RAD, as I mentioned earlier, stands for radian, and GRA stands for gradients, like which was the worst possible unit. But right now we are dealing with radians, so I will simply press 4 and I've gone into radian. I've changed into radian. The only thing that's going to be affected in radians are going to be your ratios. Other than that, everything will be the same. So if you're multiplying 180 minus multiply 6, it's going to give you 1080. And if you try this in degrees as well, it's going to give you the same answer. The only things that are going to be affected here are going to be the trigonometric ratios and nothing else. So if in case your calculator is in radian modes, your arithmetic operations or anything other than trigonometric operations are not going to be affected at all. So coming back to the question, so in order to find the base angle, I have to take the inverse of cos, and cos 0.4 gives us 1.16. So as I said earlier, cos has two values. However, in this case, we are going to see where cos is negative. We are going to consider the quadrants where cos is negative. So back to ASTC, we can see cos is positive here and here as well. However, it is negative here and negative in the third quadrant. And what we did in the respective quadrants was, here we subtracted pi minus alpha, and here we added pi plus alpha. So in this question we will do the same. So pi minus 1.16 and pi plus 1.16. And how did I know that how is cos negative? Because of this sign. We never ever use a negative sign in calculating the angle. We only use it for finding out the two possible answers. So shift and this button, and we get pi minus 1.16 to 1.98, and finally we're going to add 1.16 to 4.3. And since 2 pi is, I guess, 6.23 or something, since this domain is a pretty big domain and the answers lie within the range, so we are going to accept both of these answers. However, if for some reason the angle was 7.53, we would not have accepted this. Even if were the correct answer, we would not have accepted this unless until the domain was big. And one last question, and then we are free to go. You might recall that I said earlier that we are going to calculate cos 30, cos 150 without calculator. So let's see. So making our chord. So what if the examiner asks you to calculate cos 150 without calculator? What we do is form this grid, and we know that cos 150 will be in this second quadrant because it is 150 degrees. So 150 up till here. So essentially it is the original angle, and the remaining is the base angle. So in this case it will be 30. So we know that the value of cos 30, so cos 30 equals under root 3 upon 2. So I calculated this in the calculator, and so cos 30 is under root 3 upon 2, or in this can be here as well. So cos 30 means that cos is positive, so it is in this quadrant. Since cos 30 is positive in Q1, or where A means all ratios are positive, in the second quadrant cos 150 is negative under root 3 upon 2. Why? Because as I said earlier, that in this quadrant only sign is positive, only sign is positive, and that is why cos 150 will give you a negative answer. Both values are going to be the same. Both of the values, cos 30 will be exactly identical to cos 150. However, the signs will differ. And that is it for today, guys. I know it was a long video. I hope you liked it. If you have any questions, please drop them down in the comment section. And tomorrow I will be doing trigonometric identities. If you recall from the beginning that I derived some identities, 4 identities, so we are going to apply them tomorrow and even solve questions for finding out the angles and what we studied today. So hopefully we'll meet tomorrow. And yeah, thank you for watching, thank you for sticking. Until then, have a good day, a good night, and peace.